Welcome back to Lab AP students. Today we are going to be figuring out the answers for the KSP lab, and we'll be figuring out the KSP for cream of tartar, which you can get from the stores. But the kind of interesting thing about the substance is it is a slightly soluble salt between the potassium and the hydrogen tartrate. And the other thing is that the ion that forms in this equilibrium, this ion, the hydrogen tartrate ion, is actually acidic. And so to figure out both parts of this lab's problem of figuring out the KSP for this substance, as well as figuring out in a second substance the amount of potassium that I dissolved into the saturated solution of this, we can use titration, an acid-base titration. So here I have the two solutions. Here is the saturated solution of the potassium hydrogen tartrate. We're going to be titrating this one first to help us figure out the KSP. And then I'm going to be titrating the solution that has the KCl I added. And from that, using what we get from the first part of the lab, we should be able to figure out the molarity of the potassium chloride, or the molarity of the potassium ions that are dissolved in that solution. It's a little bit of a common ion effect, to give you a little hint. I'm going to be titrating today with what the lab suggested, 0.1 molar NaOH, and I have that filled in our burette already. And I thought I would start off with 2 trials for each, and then we can kind of see an average for our 2 trials. If we need to do a third trial, we'll cross that bridge if we need to. And the indicator I'm going to use today is good old phenolphthalein. So we're going to be looking for that light cotton candy pink to stop the titration. All right, let's begin by collecting data for our 2 trials. So what I've done is I've filled 2 graduated cylinders side by side here with the potassium hydrogen tartrate solution. And I'll go ahead and put my hand behind here so you guys can get an accurate, it's a little blurry, there we go, an accurate reading on this volume. Watch those increments, everybody. That's trial 1's data, and here's trial 2's data. Okay, let you get an accurate reading on that. And then I'm going to just pour trial 1's into flask 1 here. And I'm going to pour trial 2's into flask 2. And then what I'm going to do also is add distilled water like we did in past titrations. That'll just increase the volume. It does not change the number of moles of acid that I have floating around in there. And I'll also add 2 to 3 drops of the phenolphthalein. All right, so I added the water and drops of our indicator, and then I set up sample 1's underneath the burette. Got a little stir bar, mixing it, and then let's go ahead and get the initial volume reading for our 0.1 molar NaOH. Let me get a little bit more even. Okay, go ahead and get that volume. Watch your increments again. All right, and then at this point what we're going to do is titrate. So I'll open up the valve. I did a little jiggity jag for the burette so there's no air pocket in the tip of the burette, and I'm just going to add drip by drip here. And again, we're looking for it to be nice and light pink throughout that solution, and let it persist for 30 seconds or so, and I'll know I'm at the equilibrium. It's turning pink already. Let me pause it and see if it goes away. It's disappearing, so I'm going to add more. And I'm just going to go drip by drip here. Oop, that was a lot. Seems to be persisting, so I think I am getting close. This is not taking very much. Disappearing, so we're going to add a little bit more. excitement of it all. Here it is. I'm thinking a couple more drops. We'll see. Over or under, guys? Ooh. It's looking pretty pink throughout. We are very close. Just want to get it to persist for like 30 seconds or so here. So I'm going to try to add just one drop and not mess this up. It's looking pretty good. I'm going to go one more. And we can probably collect our data. What do you guys think? Would you say we're there? Nice and light pink. All right, let's get our data. So this is the final volume for this titration. Let me get a little bit more even with it. Watch your increments and go ahead and take that final volume for sample 1. All right, for trial 2, same thing. We got it all set up. I'm going to use the ending volume from our first trial as our initial volume for the second. Might have altered a little bit when I was moving things out and in, so I'll let you get that. And let's titrate. So we know just about how much it's going to take on this trial. Now, I did have a little bit less of the solution on this trial, so it'll probably be even less. So I'm going to take my time with this one again. Try to get that nice light pink. Start with a rapid drip drop. Nice alliteration, I know. And then when it starts to persist, we'll slow it down. Slow it down a little bit. There we go. Now continue adding drops. Very close. I'm going to try to add another drop or so, see where it puts us. Let's see how long it persists here. Ooh, disappeared. Let's add another drop. Try to get that 30-second or longer lasting color. Go ahead and add another drop. All right. That was actually 2 drops. See how it looks. I think we might be there again. It's lightening up a little bit, but it's persisting. All right, let's go ahead and get the final measurement on this one. Let me get even. Cool, I'll let you get the increments. Watch those increments, I should say. Get the measurement. All right, and with those 2 trials, I will let you go ahead and calculate out the KSP. Now that you've collected the titration data to help us figure out the KSP for just good old normal potassium hydrogen tartrate, now we're going to move on to part 2 and try to figure out the unknown concentration of how much potassium chloride I dissolved into this. So remember, K in the KCl here, that K is a common ion with the normal solubility of potassium hydrogen tartrate. Potassium, potassium. So this should have an effect and shift the KSP a bit and change and cause the concentrations a little bit. Now the KSP should remain completely constant because we are doing this at the same temperature, so the temperature is not changing in this lab. So the KSP you solved for in the first part, you should be able to use for this part. So I have the similar setup, trial 1, trial 2, and I've got the solutions already measured out. You guys just got to take the measurement. So get down for trial 1. I don't know if that helps a little bit. Let you guys see where the meniscus is. There we go. Watch those increments. And trial 2, going a little bit more. Let me get even with it and let you get that measurement. Want me to go like that to help you with the lineup? Okay. Then I'll add those to the 2 flasks that have stir bars in it. Again, a couple drops of phenolphthalein, and I'll add some water just to get the volume up. And then we will still be titrating with our 0.1 molar NaOH that's in the burette. All right, trial 1 is all set up. I've added the water, the indicator. Let's go ahead and get the initial reading on our burette. Try to get more eye level with it. There we go. And I want you guys to predict a little bit. What do you think? Is it going to take more NaOH or less NaOH with this potassium that is dissolved in the saturated solution? Take your guesses now. See if you understand the concept, and then I'll start adding the NaOH. And again, we're going to add this until that light pink color persists for at least 30 seconds. Wow, that did not take much. I hope you guys said less NaOH this time. We are right there, so it's not quite persisting, so I'm going to add a few more drops. Whoa, that was 1. We'll let it sit. We're definitely there. It is lightening up a little bit, so that's good. And let's get our final volume. Let's see. Should get in a little closer. There we go. All right, on to trial 2. All right, a little side-by-side comparison. Trial 1, and now trial 2 is ready to go. And let's get the initial volume again. I'm trying to start where I left off with the last titration. Let you grab that. I've got to pause the video to get it a little bit more accurate. Go for it. And then let's start titrating. Again, it shouldn't take much. Go ahead and open it up, let drips come out. I believe trial 2 had a little bit more solution that we started with, if I'm remembering that correctly. So probably a little bit more NaOH in the first trial. That did not take much. We're pretty close. I'm going to try to add this last drop here. See where that puts us. Try not to mess it up. There we go. Let's see how long that persists. All right, this is what I'm going to do, class. Oh no, would you say it's still pink? All right, if you like that, let's get the volume for you. If you don't like that, what I'm gonna do is add 1 more drop and get the new volume after this. So I'm giving you guys some choice here. Where is the end point for this titration? I'm gonna add 1 more drop, try not to mess it up. If you like this as your end point compared to the last one, I'll let you get what the new volume is based off that 1 drop I just added. Ever so slight. Okay, cool. Now that you have the data for these 2 titrations, you should be able to go through and figure out the molarity of KCl, or the molarity of potassium ions that are floating around in that solution. Good luck. See you next time.